Okay, the next section we're going to be doing is lesson 11.2, which is comparing data displayed in dot plots. Notice we are not creating dot plots given information. We are just analyzing a dot plot that is given to us. So, whenever we analyze dot plots, we can use dot plots to look at a set of data, especially with respect to the center of the data and the spread of the data. What our first example gives us: people once used body parts for measurements. For example, an inch was the width of a man's thumb. In the 12th century, King Henry I of England stated that a yard was the distance from his nose to his outstretched arm's thumb. The dot plot shows the different lengths in inches of the yards for students in a 7th grade class. Question A. Describe the shape of the dot plot. Are the dots evenly distributed or grouped on one side? So, you need to look at the graph and see what you think. Personally, I feel like the dots are fairly even, and most of the dots are in the middle. So now that's how we need to answer the question. Obviously, not in that many words. Come up with your own explanation to put that in. I'm going to put the dots are fairly even. And most of the dots are in the middle. So, with most dots in the middle. Now remember, I want this in your own words. You're not just copying down everything that I write down. This is in your own words. Question B. What value best describes the center of the data? So you need to look at the chart and see where do you feel like the center is, and you need to explain your answer and how you chose this value. I feel like looking at this, the number 31 has the most dots. It has 3 dots. So I'm going to put the most dots occur at 31 inches. Okay, the center has about the same number of dots on each side, is around 31.5. So if you notice, this is about where the center is. There's a pretty even number over here and a pretty even number over here. So the left and the right sides around 31.5 have about the same number. So I'm going to put the center with about the same number of dots on each side is around 31.5. On each side is around 31.5 inches. Last question for this one. Describe the spread of the dot plot. Are there any outliers? Now remember, an outlier is a number that's like way far away from all the other numbers. That's like when we look at this, our data values start at 28 and end at 35. Most of the data is between 29 and 34 inches. So because 28 and 35 are so close to where most of our dots are, we wouldn't consider those outliers. If you had a dot maybe at 20 or at 40, you can consider that an outlier, but just because they're missing one little hash mark on our graph, that doesn't make them outliers. So once again, you need to figure out a way to answer this question in your own words. I'm going to put the data values start at 28, 28 inches, and end at 35, which is just what I said a moment ago. most of the data is between 29 inches and 34 inches, so I would not consider 28 or 35 to be outliers. So you need to make sure, if they're asking you a question, that you're fully explaining your answer to make sure that you understand it completely. Now at this point, what I would like for you to do is pause the video and calculate the mean, median, and range of the data in the dot plot. Remember, mean is your average, median is the middle number, and range is how far it is from the highest value to the lowest value. When you come back to the video, the answers will be on the screen for you, but just like earlier, in order for you to get credit, you have to show the work of how you got each one of these. There is space on the sides of your pages where you can show your work. Your mean is about 31.6 inches. Your median is 31.5 inches. And your range is 7 inches. If you did not get those numbers, be sure that you go back and check your work and see where you made a mistake. So this is where you can check yourself before you continue on any further. Next page. Comparing dot plots visually. So you can compare dot plots visually using various characteristics such as center, spread, and shape. So example 1. The dot plots show the heights of 15 high school basketball players and the heights of 15 high school softball players. What you're going to do is you're going to visually compare the shapes of the dot plots. So softball, all of the data is 5'6" or less. Basketball, most of the data is actually 5'8" or greater. So as a group, the softball players are shorter than the basketball players. Next, you're going to visually compare the centers of the dot plot. The data for softball is centered around 5'4". The basketball data is centered around 5'8". This means that the most common height for the softball players is 5'4", and for basketball players is 5'8". Then you can visually compare the spreads of the dot plots. The softball spread is from 4'11" to 5'6", and the basketball spread is from 5'2" to 6 foot. So there's a greater spread in height for the basketball players. Now for your turn. What you need to do is visually compare the dot plots of field hockey players to the dot plots of the softball and basketball that we looked at before. So you're going to need to go through here. I am not going to put the answers on here for you to just copy down. You need to go through and compare their shape, their center, and their spread, just like we did in the previous example. You're going to do the exact same thing, but using the hockey players in comparison to the basketball and softball. When you're finished, restart your video, and we're going to pick up with comparing dot plots numerically. So, we can also compare the shape, center, and spread of two dot plots numerically by calculating the values related to the center and the spread. Remember that outliers can affect your calculations. They really can. It's a big deal. So you have to pay attention when there's outliers. So, numerically compare the dot plots of the number of hours a class of students exercises each week to the number of hours they play video games each week. So notice your top one is exercise in hours, the bottom one is video games in hours. So first thing, you're going to compare the shapes, just like we did before. Exercise, most of your data is less than 4 hours. For video games, most of your data is 6 hours or greater. For the second thing, you're going to compare the centers of the dot plots by finding the medians. Okay, remember a median is the middle. Your median for exercise is 2.5 hours. Even though there are outliers at 12 hours, most of the data is close to the median. The median for video games is 9 hours. Even though there is an outlier at 0 hours, meaning someone doesn't play at all, these values don't seem to affect the median. Last thing we're going to do is compare the spreads of the dot plots by calculating the range. That's the difference between our highest and our lowest amounts. So our exercise range, including your outlier, is 12 hours. If you do not include your outlier, it's only 7 hours. So see the difference in including and not including your outlier? Same for video games. Your range with the outlier is 14 hours, and your range without the outlier is only 8 hours. So that's a big difference. That changes your data quite a bit. So what I want you to do is pause your video and complete question number 3. Calculate the median and range of the data in the dot plot, then compare the results to the dot plot for exercise in example 2. So you're comparing internet usage to exercise in this one. Once again, I'm not going to put the answer of this one on here. I want to see what you come up with on your own. That's why it says your turn. Last thing for this section, I want you to go back, use your notes, use everything that we've done in order to complete the guided practice. Notice you're comparing shapes, centers, and spreads of your dot plots. You are also calculating medians and ranges. And yes, you must answer the essential question check-in. Good luck. Enjoy. If you have any questions, please be sure to ask.